Right. So, as I just mentioned, by the end of today's class, I'll be giving you your pseudocode to start. So, you're going to use this part of your mark scheme to ensure you have all of this to um, create your pseudocode and ensure you get full marks for that pseudocode. And you will also be starting your statement of problem or your problem statement. If you don't remember what those are, please watch back the video on what we did in the last class, where I explained the entire video. Now, I'm going to give you a hint as to how you can create your problem statement. If you guys can remember, the problem statement has two main parts. A problem part, where you explain what is the problem. You explain what is the issue, and you say how that issue is affecting persons. So these are some information that you're going to put inside of your problem statement. What is the problem or issue? Who is it affecting? And how is it affecting those persons? So that will fulfill the problem part of your problem statement. I will fully describe what is the problem. So what is the problem? Who is it affecting? How is it affecting them? So if the problem is that I'm hungry, who is it affecting? It is affecting me. It is affecting other persons around me, because when I'm hungry, I irritate other persons. And how is it affecting those persons? They're being bothered, they're being upset, they're getting angry. So you fully describe, you go into detail, and then you mention a solution. Obviously, so this is for your problem. So what we're looking at here is your problem statement. Remember, this is going to be done in a Word document. And for the solution part, obviously, what are you creating as your solution? What are you guys creating as your solution? What are you guys making in this SB at this part here to solve this problem?
The
Program. So your solution is that Pascal program that you're going to be making. So that is your solution. And then you have to describe how it will function to solve the issue. So that is how you will develop your and then you can give a small conclusion, summarizing all of the information so that you can end. So basically 2 paragraphs, 1 paragraph on the problem, you fully describe that problem, and the next paragraph you describe what is the solution. Please go into detail, describe what is the solution, and fully describing how that solution is going to work is going to fulfill that. How is that solution, how is that program going to solve the issue? Any questions on this part here? Questions going?
No, sir.
Questions going twice? No question? All right. So I said I would give you guys a hint. If you read this paragraph here, it gives you an idea as to what the issue actually is or what you're trying to do. So read that paragraph and that will give you an idea as to what you need to put into this part of your problem section of the problem statement. Alright, so that's your first task there for your programming SBA. Remember once again to use your mark scheme as your guide, and your instructions are inside of your this PDF here. Develop a problem statement for the algorithm developed. So the other task I said I would have given you is your pseudocode. So today we're going to be looking at how do you develop a pseudocode. All right. Alia, could you read those paragraphs on the screen? Ali is not there. Brian?
Pseudocode is not programming code, but uses English type words and phrases that are clear enough to be easily converted into programming code. It uses the same statements, keywords, variables, conditional statements, and loops described in the previous section to create the instruction for a solution to to a programming problem. Pseudocode can also be developed from an Ipo chart to specify what data is input and processed into information. Let's first review the Ipo chart that finds the sum of three numbers.
Good. So please take note of this here. A pseudocode is not a programming code. It is not a programming language. It is not. It is used as a guide to create a programming language. Or sorry, it's used as a guide to create the programming code, not the programming language, because you cannot create a programming language. So it's used as a guide to create that programming code. Your pseudocode is made up of English words. So everyday words that you are speaking, that is what the pseudocode will be made up of. So whatever, whoever is going to read this pseudocode, it should be clear to them that this is exactly what is going to happen. So, but even though it's only English words, you're still going to use the same statements, keywords, variables, conditional statements, and loops. So the programming language is going to have statements and keywords for different features and options in the programming language. But you don't need to know those keywords. You could use a general word that would represent it. For example, look at this one over here. It uses the word add. Add is not necessarily the keyword in Pascal to add those two variables together. But you're using a normal English word, excuse me, but you're using a normal English word so that you or anyone that is reading this pseudocode will have an idea. They will know exactly what is supposed to happen in this line of the code. They will know exactly what is supposed to happen. So that is why it's in English, so that anyone is reading it, they can understand it. Excuse me. So as I mentioned in one of our previous class, to develop your pseudocode, you can use an Ipo chart. An Ipo chart is not a chart, but it is a table that is used to list all your input, all your processing, and all of your output, so that when you're creating the pseudocode, you will know what you need to input, what you need to calculate, and what you need to output. so that you don't have to go and worry and wonder, what am I supposed to input? What am I supposed to calculate? You don't have to wonder about all of that. You already have all of that information in your IPO chart. Excuse me. So that's another thing you can create also, your IPO charts. So, SBA tasks so far that you guys are gonna have. You're gonna have your problem statements to start. You're gonna have your IPO charts, and you're gonna have your pseudocode. So I'm giving you those three to start there. So we're gonna look at an example of developing this pseudocode. So let's first review the IPO chart that finds the sum of three numbers. So notice this IPO chart that was created. The input, remember they're adding three numbers, the sum of three numbers. That's the purpose of their program, adding three numbers. So their input is going to be those three numbers. Now, what is your processing? Your processing is going to be adding those three numbers together. So notice it's in clear English words. Add the three numbers together. And what is the output? Output the result of the addition. You can even say output the addition of those three numbers. Once it is clear as to what is being done exactly, then you have a IPO chart. Now note that the variables number 1, number 2, number 3 will store the first, second, and third numbers that are input. So this is how we usually name our variables. For example, if we're going to enter three numbers, we give it a standard name, number, and then we give it a slight variation at the end. So number 1, number 2, and number 3. So it's very clear that number 1 is going to be the first number, number 2 is going to be the second, and number 3 is going to be the third number. So whenever you're naming variables, it should be clear as to what they are exactly. Excuse me. So the processing column, as you can see here, the processing column involves short statements explaining how the data is managed. Here the values are that were input into the variables number 1, number 2, number 3 are added. So the values that you're going to enter into these three variables, under the processing column, you will add those three numbers together. The third column indicates that the result of the addition is output. Are you guys following how an IPO chart can be created?
Yes, sir.
All right. So the name of the segment of pseudocode is add three numbers. So remember, one of the first things we need to do when we're creating a pseudocode is to have a title. The title is going to give us an idea as to what the program is about. So add three numbers, that's the main purpose of this pseudocode here. So the keywords input and output are used to indicate that data is input, usually using an input device such as a keyboard, while the output can be a soft copy on the screen of a monitor. So keywords as input indicates that you need to put data into the computer, and usually that is done with your keyboard. because it doesn't ask you enter a number, enter a name, whatever the case may be, and you usually enter that with a keyboard. Remember, we're just looking at a basic program. Yes, you can use voice assistants and so on, but we're looking at a simple program. So we're going to use a keyboard to enter that data. And when you want to output, yes, there's different ways that you can output. You can print the output, you can output it as sound, but we're once again creating a simple program, and we're going to output on the screen of our monitor, of our display. So, 1, you must have a title. 2, you're going to use keywords such as input and output to indicate those. And 3, you're going to use the keyword end or stop to denote the ending, or where your pseudocode has stopped. And you would use start to indicate where it begins. So it's important to indicate where your pseudocode begins from and where it ends. Any idea as to why you would want to indicate where your pseudocode starts and ends? Any idea?
Because if you have multiple different types of code, you wouldn't want it getting confused.
Okay, if you have multiple different codes, okay. But then if you have multiple different codes, then that can be more than one program. Because if you stop and you start another pseudocode, that's going to be technically another program. But what I'm trying to also get at is that, so say you say start here, and you say end here. So this is your main body of your pseudocode. This is where you're going to convert into the program. Now, this entire outer box here is your pseudocode also. This is all what you would have created for your pseudocode. Now, but inside of it, this small section here, you're indicating a start and stop, start and end. That's the what you're going to convert into your program. Now, why would you want to do that? Well, maybe outside of it, you're going to have comments at the starting and at the ending. You might have comments where you might say, you might give like some simple guide and instructions and say that how, like, add supplementary information, that where the data is going to be gathered from, how are you calculating this data, why are you calculating it, where the data is going to be output. So it's supplementary information that might be added. It's not necessary to add comments, but it's, you got to think about it. If somebody is to read your pseudocode, it might add more information to your pseudocode so that persons are clear as to what exactly you're trying to do. So that's why it's important for you to indicate where it is starting and where it is stopping, so that you know that this is the starting point of my programming code and this is the ending point of my programming code. So I know I don't have to add these comments into my programming code, but you can still add them as comments in your program. Because remember, a part of your mark scheme says that your program should have suitable inline comments. So that's part of your documentation there also. So inside of your program, you're going to indicate, you're going to add some comments. So for example, I'll give you guys an example. Input number 1, number 2. Just imagine this is a line of code inside of your program. you can add a comment right next to it and say something like maybe numbers are gathered from spreadsheet program, so that you know exactly where the numbers are being taken from. Numbers are taken from the spreadsheet SBA program, Excel, something of that sort. So, and that's basically it. What you need to do for comments, you indicate, give more information as to what is happening. So, creating your pseudocode, ensure you have a title, number one. Ensure you use keywords such as input and output, and you indicate where your program pseudocode is starting from and where it is.
Sorry, looking a bit too infectious.
Is a vaccine that I took the other day. I'm gonna get a mint. Yes, I'm back. So, yeah, those are your instructions. There are some of your instructions for your pseudocode, developing your pseudocode. Now, the pseudocode in example 5 is produced from the Ipo chart. So this is the Ipo chart. And we're going to look at how that pseudocode is developed from that here. So remember, these are the input. Input 3 numbers, add those 3 numbers together, and then output the result of that addition. So example 5, firstly, notice your title. So you're looking at an example of a pseudocode. Now remember, I told you guys that you can actually use these examples as a guide. So you have assistance. You can actually reuse this part here as input. You have this is the guide as to how you are going to structure your input. So whatever you need to do for your pseudocode, just look at one of the examples and see if it matches what you need for your pseudocode. So firstly, we have a title, pseudocode 5A, add 3 numbers together. Why is it that we have underscore between each word? We learned this in
To
database.
separate them.
Separate. You sure to separate or the opposite? It's actually to join them together, not to separate them. Because we would have learned already in database, when you're giving something a name, are we supposed to use space?
No, sir.
No, sir.
No.
No, sir.
You're not supposed to use space. You can, but sometimes it causes errors when you use space. Because, for example, if you're going to give a variable name, like for example, this variable here, and you name the variable number, and you put a space, and then you put 1, it's not going to recognize this here. it's not going to recognize number space 1 as a name because it's going to consider it as separate. So the you use underscore or you use no space at all. So basically join words together. So please take note of that. Anything that you're naming, either use no space once again or you use underscore. So we have the title, we have our inputs. So we have our input section. We represent that with I. And then we have our processing. Add number 1 plus number 2 plus number 3. And then we have our output. Output the result of number 1, number 2, number 3. And notice they actually don't have a start, but you guys are going to indicate a start. But here it indicates the ending. I'm wondering if the title indicates the start in this case, but you guys are just going to simply put in the word start. So yes, it's very simple as to how you create your pseudocode. So you guys are just going to read the instructions here. We already went through this. Create your Ipo chart. Map out what is all of your input, what is all of your processing, what is all of your output, and from that now you figure out what do you need to do as processing, what do you need to calculate, and you create your pseudocode. So let's look at some more examples or a description of this pseudocode. If the 3 variables that contain the 3 numbers have the same data type, remember we learned about data type in spreadsheet and database. Data type basically means what value is going to be what type of value is going to be stored in that variable. So for example, those 3 variables are an integer data type. Then the statement to input the values can be placed on one line as shown in the updated pseudocode. So remember, we try to make our pseudocode, our program, having less lines basically. So if you notice, we can actually put it like this here. We put our compared to input number 1, input number 2, input number 3 in 3 different lines. We can put it in the same line because they are the same data type. So here we have our input, here we have our processing, here we have our output, and then we have our end here once again. If you guys cannot remember your data types, I think it's mentioned in chapter 9.2. We have integer, real, character, string, and boolean. Those are our 5 data types that we're going to focus on. So now that we are familiar with variables, we can also place the result of the calculation in a variable. Let's name this variable results. So before we move on to that example, do you guys understand what is happening in this pseudocode here?
Yes, sir.
Or do you want me to explain it once again?
No, sir. Answer.
Alright. So for those that are not answering, once again, you basically input number 1, number 2, number 3. You put in your 3 values. Next we have our processing. You add those 3 numbers together. Then you output those 3 numbers. Output the result of number 1, number 2, number 3. And then we end. Now the next example, remember it's the same pseudocode, but just that we are further refining that pseudocode. We are further making it better. So That's why this one is 5C. It's the same pseudocode, but we're just making it better. So we're inputting once again. We're inputting those three numbers, input number 1, input number 2, input number 3, and our processing now. What are we doing? Anytime you see an arrow or anytime you see a variable on the left hand side, please remember that the calculation that is being done on the right hand side, or even if it's a value, say for example there is no calculation, there is a value, and say for instance that value is 40. What this basically means is that this 40 is going to get stored inside of the variable results. So anytime you see a variable on the left hand side and some sort of calculation or some sort of number, it is indicating that that calculation or that number, the result of it, is going to get stored into that variable. And in programming, you're going to usually see it as an equal sign. But remember, we use an arrow because we want to. You can, instead of the this arrow, you can actually use equal sign, because that would be a bit more clear that the result of number 1, number 2, number 3 is going to get stored inside of the variable results. So that is why as the output, you're going to output what is inside of the variable results. Because remember, the calculation was stored inside of it. Are you guys following?
Yes, sir.
Yes, sir.
All right. When there's 3 persons that I'm expecting to follow are following. So continuing, the new variable results on the left side of the statement will contain the answer from the calculation of the numbers from the right side of the statement. That's what I just mentioned. What is on the left will contain the value that was on the right. Calculations can include the left arrow, as you see in this example here, or as I mentioned, you can use the equal sign. So it might be more better for you guys to use the equal sign, or you can use the arrow, which one ever you know you understand, or which one is more clear to you. You use either symbol to indicate that the result of a calculation is going to be stored into that variable. So here is yet another set of pseudocode for example 5. Same example, further refining it, using different keywords. So read, which is going to be similar to what?
Input.
Input. And print, which is going to be similar to what?
Output.
Output.
So they basically mean the same thing, just that we're using different keywords. So, and the keyword end can also be used on its own to denote the end of the statement. So because if you notice, they were using end of pseudocode all the time. So you can simply say end to end your pseudocode. So once again, you have a title, pseudocode underscore 5D, add 3 numbers. You have your input, which is read the 3 numbers because they're the same data type. We have them in the same line. Then we have our processing. Number 1 plus number 2 plus number 3 is going to be stored in the variable result. And then we have our output, which is to print the variable result. And then we end our pseudocode here. For those that cannot remember those statements, that is inside of 9.2 also. We looked at input, read. Those are the two that indicates input. Input and read indicates input. And output, display, print, and write. Those four indicate output. So what you have in blue indicates input. So it's important to remember those keywords. Alright, is everyone clear on how to make a simple pseudocode?
Yes, sir.
Yes, sir.
Yes, sir.
Alright, so it's very simple. A simple pseudocode, you take your Ipo chart, and in the pseudocode, you simply indicate what is your input, what is your processing, and what is your output. And you indicate with a title, that is the starting point, and you indicate the ending point. That is a simple pseudocode there. Now, we're going to look at adding more to our pseudocode. So we're going to look at sequential statements. Sequential statements, such as those in example 5, are executed one after the other from the first statement to the last. So what does the word sequential mean?
Sir, like an order or something.
In order. So whatever is being carried out, it's done in that order. So if you number something 1 to 10, 1 has to occur before 2, 2 has to occur before 3, 3 has to occur before 4. So that is what they mean by sequential statements. Each line is considered a statement. And so one line has to execute first before you can go to the other line. So that's what they mean by sequential statements. So if you were to number this pseudocode here, read is going to be 1, this is going to be 2, this is going to be 3, and then we end there at 4. So you cannot print a 3 if you did not complete 2, and you cannot calculate a 2 if you did not read at number 1. It must go in that order. So let's look again at the Ipo chart from example 2, which finds the average temperature of 2 values. So our Ipo chart, we are inputting 2 values. We're inputting the maximum temperature and the minimum temperature. And you guys should know the simple mathematical calculation to get average. Add the two numbers together, or add how much of a number there is, and divide it by those amount of numbers. So to get our average, we add the 2 temperature and we divide it by 2 because it's only 2 values. And then we output average temperature. The following pseudocode is produced using the sequential statement from the information in the Ipo chart. So this is our pseudocode from this Ipo chart at the top. We are finding the average temperature. So notice this once again, our title, pseudocode 6a, find underscore average underscore temp. Now, it's important to note, not important, but you can also shorten certain words. So you don't have to type out exactly temperature. You can type out temp, average, you can use AVG, and things like that. Instead of saying maximum, you could say max, and those kind of ways that you can shorten words. Remember, there's a limit of the size that you're supposed to name variables. There's actually a limit. You're not supposed to give it a too long name. So for example, this one here could have been short and this one could have been avg underscore temp to make it even shorter. But you also have to keep in mind, don't make it too short and then a person does not know what they're looking at. So we're looking at another pseudocode. We have the title there. We have input. So we're inputting the two temperature, max underscore temp and min underscore temp. And obviously, they're going to be the same data type. So that's why we have them in the same line. Next, we have our processing. So remember what is on the right, and notice our equal sign is going to be transferred to the left. So max, and notice we have brackets. So the same BODMAS is going to apply once again. So brackets first, and then division. So we're going to add these two numbers together, max and min, and then divide by 2. And that is going to be stored inside of average temp. And then we have our output average temp, and then we end our pseudocode here. Are you guys clear on that?
Yes, sir.
Yes, sir.
So first, the value for the maximum temperature is input. You can see that here. Maximum temperature is input first. So whatever you put first on the left, that's what you input in first. That's what it basically means. And the value for the minimum temperature is input into the second variable, min temp. The resultant number from the calculation is placed in the variable average temp, and the result stored in average temp is then output. So we look at 2 examples there. Those are 2 examples of creating a simple pseudocode. 2 examples of creating a simple pseudocode. If there's anybody that doesn't follow on creating a simple pseudocode, please say so now, because we're going to be getting into complicating the pseudocode now. Because now we're going to be looking at conditional branching, which adds more to our pseudocode. So if there's anything that you guys want to clarify on the simple pseudocode, please let me know now. So remember, as I mentioned,
Could you just go back over the very last part there?
which part?
Where you explained right here in the box.
This one here?
Yes, sir.
Explain back the entire pseudocode.
Yes, sir.
So this pseudocode here, first we have our title at the very top. Then we have our inputs. So the input keyword is indicating that whatever we type in is going to be stored inside of these 2 variables that we have here. So we have 2 variables, max underscore temp and min underscore temp. And because they're the same data type, more than likely they might be a real data type because they're temperature. So there might be some decimal places toward it. So both of them might be real. So they would be placed into the same line because they're the same data type. So we're inputting those 2 values, and they're going to be stored inside of these 2 variables here. Max is going to be first. Whatever's on the left is going to be stored first, and then what is on the right. That's when you're inputting. Now when you're processing now, what is on the right hand side is going to be calculated, and the equal sign, it means it's going to be stored inside of this variable over here. So calculations in any part of IT, it's always going to follow BODMAS. Mathematics is always going to follow BODMAS. So brackets are going to be carried out first. So the addition of these two variables are going to be carried out first, and then we divide by 2. That calculation there is going to be stored into average temperature, the variable average temperature. That's what this here means. What is on the right? Because obviously, if you look at it logically, you have a variable on the left hand side, and this variable is going to be empty because you have nothing in the beginning saying input into average temperature. There's nothing in the beginning saying that. So this variable is going to be empty. Now you have a calculation on the right hand side. So obviously this variable on the left hand side, you can't do anything with it. Even if you output in this line here, you're going to get 0. There's nothing inside of it. Now on the right hand side, you have a calculation. This is going to be calculated. Say it's 2 over 2. That's going to be 1. 2, that's going to be 0.5. I hope my maths is correct here. So you have a calculation there. 0.5 is the answer. Now what are you going to do with this 0.5? You're going to just leave the 0.5 there? No. You're going to take that 0.5 now, and you're going to store it inside of average temperature. Because in the first place, you could have done nothing with average temperature by itself. So now you're giving average temperature a value. Now because it has a value, now you can do something with average temperature. Now you can output the average temperature. So when you output it now, you're going to get that 0.5 as a result.
Sir, so you know how we didn't have average temperature until we did the BODMAS part there?
Mm-hmm.
So in order for us to work with average temperature, we would have to do all this first, or could we still continue before we ended it?
Go back to your question.
Like, we couldn't do anything with average temperature because we didn't have a values yet. That's why we needed to do the BODMAS part, right?
Right.
So could we not? So we have to, like, can we put another line under there before we put output?
What are we putting in the line?
Like using the 0.5 as a value, or it has to be output first?
Now remember, in this line here, in the processing line, it's going to get the value.
Oh, right, yeah.
So in the processing line, it's going to get the value. So that's why output is next. Now, there's a lot of things you can do also. Remember, this is just a simple pseudocode, because in the very beginning here, what you can also do, like in the very beginning here, you could add something like average temp is equal to 2. Average temp is equal to 2, so that when it reaches here, it actually has a value of 2. But obviously, not obviously, because you guys might not know, but when it starts off, you can see, when the pseudocode starts off, you can see it started with a value of 2. But when it goes through the program now, when it goes through the algorithm and it reaches this stage here, that 2 is going to change because some sort of calculation is going to be carried out. And when it is carried out, based on the same, maybe that same 2 divided by 2, if a person entered 2 for both, and you get that 0.5 once again, then that is going to be stored now in average temperature, and it's going to overwrite that 2. So that's why the 0 that was there got overwrite. So you can give a variable a value before, and later on you can change it based on a calculation, or you can even say give it another value. So even after you did this calculation and say this average temp got 0.5, before you output, or even after you output, you could create another line, because anything is possible. You could create another line right after output, because this output is going to be 0.5, and you can create something else saying avg underscore temp equal 10. There was no calculation, but you say it equal 10, and then you could say output average temp, and it's going to give you 10, even though that was not what was calculated. Think you follow me what I said?
Yes, sir.
So anything is possible with programming, but obviously you're going to want to keep it logical, to keep it with a flow that it makes sense, that because you're going to want the accurate value, because this last one here, it's not a true value. It's not what average temp is supposed to be. So yeah, all of that is possible. Any other questions? Alright, it's already 1:32. If you guys have more questions, we just look at questions for now. Next week, we're going to start conditional branching, because that is a lot of information. Because think of conditional branching like doing your if formula inside of a spreadsheet. So if you guys can remember if in spreadsheet, when we did if equal if 8 is less than 10, I don't remember the rest. Then output true, else output false. That was your if statement inside of your if formula, your if function. That is your if function in spreadsheet. So if you guys can remember how this works, it's similar that you're going to be doing for in your programming. It's a similar idea. First, you have a test. If 8 is less than 10, or in most cases, what we're going to be doing is checking a variable. So we could say if average temp is less than 50, then we could say it is cold. We can output the word cold, or we can output the word hot, because it is false. It's not less than 50. So it's the same thing we're going to be doing for conditional branching, but we have different ways of creating those conditional branchings. So next week we're going to look at that. So what do you guys have to work on for now for your SBA? You're going to create your problem statement. Well, obviously, before that, you actually need to finish your web page SBA. So I hope I don't have to start calling names soon, so that you guys know who are not finished. But ensure you complete your web page SBA. You have your problem statement. I already gave some instructions on that. The recording is going to be posted, so if you need to go through back that, you can do so. Your Ipo charts, you're going to create that, and then you're going to start creating a basic pseudocode. You don't need to create the full pseudocode. We just learned how to create a basic one. So see what you can do to using your mark scheme and your instructions here to add in those basic parts of the pseudocode. What you need to input, what you need to calculate, and what you need to output. You guys think you can handle all that?
Yes, sir.
Great. So remember, use the mark scheme as your guide. Remember, I showed you guys how to start your algorithm. Identify user-friendly variables. So this is actually not mentioned in the pseudocode examples, it just says to input age and so on. But for instance, this example here, example 5. Now it says input number 1, input number 3, number 2, and so on. But if you notice, it actually does not tell you what is the data type. You are having to guess what is the data type. So actually, what you're supposed to do is before this here, you're supposed to indicate, or as the mark scheme mentioned, identify your variable names. So what you're gonna do, you're gonna name a section called variables. You're gonna put a line called variables right before this here, and you're gonna list your variables. So for example, you're gonna say number 1, and number 1 you're gonna say equal to, and you choose your data type, what your data type is gonna be. So you only have 2 number data type. Is it going to be an integer or is it going to be a real? So you're gonna say n1 is going to be maybe a real, n2 is going to be a real. But if it's all the same data type, you can also do n1 comma n2 comma n3 comma equal real. That's indicating that all those variables belong to the same data type. Are you guys following?
Yes, sir.
So
Yes.
that is how you identify your variables. So all of your variables, so another one is going to be result. Result equal real. I think that's the only only 4 variables there. So that is how you identify your variable. Now initializing your variable. What is meant by initializing your variable? Initializing basically means to give a value. Give a value. So at the very beginning, you could say num1 equals 0 or result equals 0. Because remember I showed you guys that the value can change later on based on the input. So remember, all of this is going to be before the input. So even though you say number 1 equals 0, when somebody inputs something, that value is going to take over that 0. So why do we have to initialize? Well, sometimes, especially when your program loops, because that's what we're going to learn later on. When your program loops, for example, this result here, or any variable, if it has a value, sometimes that value remains. So, for example, if at the end of this program, result has a value of 20, when the program restarts, it can still have that value of 20, and maybe it can affect the program. It all depends on what you are doing in the program. Sometimes it can affect it. So initializing helps to basically reset all your variables, reset them all to 0. So when your program starts up back, it starts up back from a clean slate, basically, so that any old values does not get reused and basically mess up your calculation. So that is what is meant by initializing your variable. Next we have request for data. So that's where you're gonna say input. So you're telling them to input, you're telling them to put in data, you're requesting for data. You have to store data. Storing your data is when you in this, which example? This example here. When you add the 3 numbers and you store it in a variable called result. That is storing your data. And then, well, we haven't covered this part here as yet. So selection and looping, we're going to look at that in the next class. All right, so anybody with any questions?
Question: could you like include two functions in one line, or should you separate them?
Two functions. It's better to separate because you don't want too much code into one line. The reason why you can put something like this here into one line, because it's not that impactful on the program when you have to manage it or to go through it. But especially when you're calculating, when you're doing calculation, when you're doing processing, you try to put individual parts into its own logical step. Did that answer your question?
Yes, sir. Answered.
Any other questions?
No, sir.
All right. Great. So you guys know what you got to do. You have all of your tasks. So if you guys don't have any questions, that is the end of today's class. Enjoy the rest of your day.
You too, sir.